Dwayne Beck, Dakota Lakes Research Farm. I manage this place. Brennan Lewis is a graduate student in agronomy, horticulture, and plant science that's going to be working on this project. This project's funded by the NREC, the Nutrition Research and Education Council, and they look at soil fertility issues. One of the big issues we have in farming is we tend to have some phosphorus that moves from our landscapes into waterways, and that can cause algal blooms and lakes turning green, which we really don't want to have happen. So we're attempting to do a study that defines a little bit what happens with phosphorus in these long-term no-till systems. This field here is in a diverse rotation of 2 years of corn, a year of soybeans, a year of wheat, and then another year of soybeans. It's in the soybean phase, second soybean phase. It was in wheat last year. You see the wheat stubble on the soil surface. After wheat harvest, we grew a cover crop of oats, barley, and peas, which was swathed and grazed this winter by cattle. So you'll see the odd cow pie here yet. The big issue with phosphorus is, does it run off, and how soluble is it? On this part of the study, we're looking at where we place the phosphorus. We have it where it's placed in the ground at seeding time, or where we broadcast it on the surface. A lot of phosphorus in the U.S. is still broadcast on the surface. What Brennan is doing today is measuring runoff under irrigators, or under this simulated rainfall. How fast are you putting the water on, Brennan?
Well, for this experiment, we're putting on about 19 inches an hour. On other fields, we've tried doing it at slightly lower rates, but with the soil structure we have here on these fields, it just infiltrates too quickly to generate any runoff. So we're putting on some super high rates of water here.
So we're actually making it run off, and we have runoff going into that beaker there, and that gets measured and also will be sent away for analysis of what this, if you get a big rainfall like we had a few days ago up north, 4 or 5 inches in a very short period of time, what runs off with the water. And then we're also looking at what, when it goes in the ground, what happens there. So we have a tube on the edge there that goes down underneath, and it's extracting solution from the soil underneath where all this water is going on. So if it's getting pushed deep, we'll catch that at the same time. And then we have another tube that's over here where it's not getting excess water. So that's what is kind of normal. This is if we had a big rainfall moving phosphorus someplace. And Brennan sits out here and does these. It takes quite a while. It's kind of meticulous work. He's actually done now, so he doesn't need to grab that one anymore. So if it gets full, we don't need it. The irrigator in the background, this place started as an irrigation research farm at one time to stop runoff. So as he said, it's very hard to get runoff under irrigation. We will put 2 inches of water on in 9 minutes with that irrigator, and we get no runoff. Now he's putting on 20 inches an hour, which in 10 minutes you're putting on 6 into 20, so over 3. So yep. Yeah, and he does that for a long period of time, so we'll finally get some runoff.
Luckily on this field, we at least in this area, it seems to have ran off a little bit faster, so I'm able to get some really good results from it for our runoff data. It'll be interesting to see when we send these off to the lab what our results are going to be differing between our two treatments here, surface applied, broadcast, or our banded by the seed. So that'll be interesting to see.
Earlier this week we had 2.6 inches of water rainfall. So the stuff we did before this week was on soils that weren't quite as wet as these are. So that's one of the reasons we get more runoff too. Anyway, he's doing a good job. I'm glad to have him on board.
Thank you.